Here our first step is to define the mass source. To define the mass source, before that, as we see, our whole model should be checked. There should not be any error, whether it is a modeling error or any other errors. So in mass source there will be three options. First is element mass source, additional mass and specific mass. So additional mass is like, suppose it's like there includes any additional cladding, and element mass will define mass using mass per unit volume of material defined. But here we will use the specified load patterns in that. As per IS 1893 table number 10, it will consider 100% dead load along with 25% live load when your live load doesn't exceed 3 kN per meter square. Here I am taking 50% because our live load will be more than 3 kN, just for showing you. If you are defining the brickwork separately and any other load, that you have to add in this. Next I will go to define a response spectrum function. So here you can see there is a one default response spectrum function already defined, but we have to define the response spectrum function according to the codes and the region. So here we'll select 1893-2016, and that after that you have to just click on add to the function, and the response spectrum definition will be open. And you can see first option is to define the seismic zone. It is given in annexure E of 1893 as per the town. So here we are considering our seismic zone of the town is 5. So zone factor will be 0.36 and the importance factor is 1, which is given in table number 8. And the soil type is 2. As per geotechnical report, we have to decide the soil type. And after that the response reduction factor, that we are taking 5, because as per the clause 3.8 there will be two types of resisting frame. One is special moment resisting frame and one is ordinary moment resisting frame. So this SMRF is the frame which is specially detailed to provide ductile behavior as per the requirement, and which is given in 13920/2016. So these are the system which participates in the resisting forces induced by earthquake. After this we have to define load patterns for seismic case. So that case we have to define in two direction, x and y. So this will come under linear static load case. So this load case you can define also when you don't want to do response spectrum analysis. Just for linear static earthquake you can define and check the model. After this we have to modify this lateral load in x and y direction. So you can see here where the direction will be the x direction, and the other options we have to untick. So eccentricity will be arise from the center of mass and the center of resistance. So this is that between two. So that design eccentricity you have to consider as per clause 7.8.2. So as here you have defined the same seismic zone, soil type and importance factor as per 1893, and the response reduction factor will be same, which you define in response spectrum function. Also you need to consider carefully the story range, top story and the bottom story. So if you check the story range, it will also define the height as well. So this excludes the basement stories, where basement story walls are connected with the ground floor deck or fitted between the building columns, but include the basement stories when they are not so connected, which is written in the clause 7.6.2. Time period calculation is given in the same clause 7.6.2. Here I am just checking the option as program calculated. Same steps will be going to add up for the earthquake in y direction. So here all things will be same, but the time period calculation only will be the different, because that is the base dimension of the building at the level along the considered direction of the earthquake shaking, which will be different in x and y direction. But for simplicity I am using the program calculated time period. Now you can see in our the load cases option, the EQX and EQY have been defined under the linear static load case. Now we have to define, so now the load case type will be the response spectrum, as there are other load case type as well. So there are other option as well. So you can see the load type is acceleration, load name u1, and the function which we have defined earlier that we have to select, and the scale factor is the default. So you have to give the load case name. Here I am giving the name as specs in x direction, so you can give any other name as well. So the things which are in the other parameters such as model load case, which is model combination method CQC, directional combination type SRSS, that I am keeping default. Same we have to define now for y direction as well. Now the load name will be the U2 for the other direction, and all the same other parameters will be same which we define for spec x. So for spec x and y, other parameters will be also same and default. You can do change, which I have tell you in the first part of the video. Depends on the requirement, you can alter the parameters. So until now our both load cases part is done. So next part and the mostly end part is that you have to see the model case. So the model case subtype we have already discussed in the part 1, which are the two known subtype. One is eigen and second is RIDS. So here eigen is the basic analysis type, but CSI recommends using RIDS type while using response spectrum or time analysis, because RIDS is more sensitive to model geometrical issue and load variation complexity, or it may not run in some cases. So throughout the check of the structure, geometry and loading is needed, or switching to eigenvector type. So we will be moving with the eigen, and the minimum number of modes should be 3. And about P delta setting, for relatively high-rise buildings, some authorities required conducting P delta analysis on the structure, but here P delta I will show you or cover in next videos. So this is about the model case subtype. So this is about the defining, and so the final analysis part I will be covering in the part 3, which will be the last part of the dynamic analysis and static analysis. Thank you so much. See you in the next video.